Hello, everybody. Welcome to Restoration 2, Restoration Conservation 2. I'm Sarah Babulis, Habitat Project Coordinator for Partnership for Delaware Estuary. Thank you for coming. Please reach out in the chat if you have any general questions during the session, tech related or anything like that, and someone will help you out. Please be aware that all sessions are being recorded and the chat threads will be saved. The recordings will be available via Sched and YouTube and our website after the summit. During the session, there are 2 opportunities for questions depending on time. Each speaker may have a few minutes at the end of their presentation for questions, and these questions we will get selected via the Q&A box, so please put them there. We will answer them as time allows. Not everyone may have time. But then at the end of the session, there will be an open Q&A session for all speakers. And the questions can be directed to any of the presenters for any of the topics. We encourage you to use the raise hand feature. We will call on you to speak so we can hear your lovely voices, but we will also take questions from the Q&A box if there are any there as well. Kurt Chang from PDE will be handling Q&A. You can, and he will jump in. All right, so let's get started. I'm going to throw it off to Martha Maxwell Doyle, our moderator, to introduce herself and our first speaker. Martha.
Good afternoon, everyone, and welcome. I'm Martha Maxwell Doyle. I'm with the Barnegat Bay Estuary Program, and this is my 9th Delaware Estuary Summit. So it's nice to be here, but I wish we were all together. That said, let's get started. Our first speaker is Lenore Tedesco. She's with the Wetlands Institute, and her topic is using dredge sediments to uplift marsh, build subtidal shallows, and provide wetland edge protection in 7 Mile Island Innovation Lab in New Jersey. Lenore?
Can you see my screen?
Yes.
Okay, good afternoon, everyone, and thanks for joining us today. I'm going to be talking about using dredge materials on 2 projects to uplift marshes in the 7 Mile Island Innovation Lab. My co-authors today are Monica Chaston of the U.S. Army Corps of Engineers, Lisa Ferguson and Sam Collins from the Wetlands Institute, and Christina Davis from the New Jersey Division of Fish and Wildlife. The 7 Mile Island Innovation Lab is a collaborative partnership to advance marsh restoration techniques using dredge sediments. The laboratory encompasses about 24 square miles and 15,000 acres of back bay tidal marshes, shallow bays, and inlets. It's bisected by the New Jersey Intracoastal Waterway, shown here in white. There are a whole host of projects here that have been ongoing over several years with many different partners. They're kind of abbreviated throughout this. And this is the back bay area behind the communities of Avalon and Stone Harbor. One of the interesting areas, components of this is these prior placement areas. These prior placement areas are they're historic placement places, and effectively this is beneficial use that was unintended. Anywhere we've had navigational channels that were either created or being maintained, historically materials were placed either on the marshes, built islands, or underwater placement. These were really unconfined placements. There wasn't a lot of engineering on this, and it's really only been roughly the last 50 years or so following the Clean Water Act that we stopped putting material in marshes. And now we're trying to gradually work back towards how we can use material beneficially. And the image on the right, you can see historic placements mapped in the northern portion of the 7 Mile Island Innovation Lab, shown in green, and there's quite a few of them out there. There's more than I've even shown there. And it turns out that these areas now are important habitats, and effectively almost all of the remaining high marsh in the entire 7 Mile Island Innovation Lab, and I suspect in a lot of other places, actually occurs on this historic fill. In this particular area, these habitat areas are important wading bird nesting habitats. So the areas 98A, B, and C, you can see are then circled with the yellow is where we have important bird nesting habitat. And they're on these high areas that are higher marsh. And these wading bird colonies account for 27% of the colonial nesting birds in the state of New Jersey. And they're on these remnant high islands. They're all experiencing habitat degradation now. They're quite old. We're seeing elevation loss, and now we're starting to see impacts to nesting success. So the use of these legacy sediment areas and then actually trying to restore to them is a strong component of the work we've been doing. The islands I'm going to talk about are Gull Island and Sturgeon Island, shown on the left. This is a drone image at high tide, and The bird areas are shown in the tan coloration, and then the rest of the island, you can get a really good idea how low Gull Island is, and it's really just subsiding, really losing a lot of marsh elevation. Both islands are dominated by low vega Spartina flats that board directly with open water or effectively functioning as low marsh, and there are places where it's transitioning to high vega Spartina. It's kind of a confused setting out there. When I looked at New Jersey Flood Mapper, we just kind of did a 2050 2-foot rise to get an idea of what the future looks like for these islands. You can see large portions of Gull Island, the almost entire southern portion, is projected to convert to flat. A significant portion already has, and as well as open water. The same is true for the northern part of Sturgeon Island. In red is where we're seeing erosional southern margin, and other margins to marsh edge erosion. And effectively, the idea was we needed to go into these places and try to see if we can uplift these marshes and help out these bird colonies. I'm going to start first by talking about Gull Island and just talk about the project goals. We focused on the southern portion of Gull Island. The idea really was to not go in and try to restore the bird areas directly. We wanted to create habitat for them. We know it's going to take some time before they're suitable for the birds to try to move to those areas. So we wanted to move away from the areas, but create habitat for them. So the ecological goals are to raise the elevation of the southern marsh platform and really across the whole gradient of elevations. These are going to be unconfined placements, so we wanted to target wading bird nesting elevations. As I mentioned, this is really transitional upland shrub habitat, which is above about 3.5 feet nav D88, where we wanted to have an apron on a large area that is lower than that for salt marsh sparrows, so 2.8 to about 3.3 gets us to the elevations we want for Spartina patens. And then we wanted to elevate some of these open flats back up to elevations for low marsh for Spartina alterniflora, and that would be 2.1 to about 2.7 as the primary goal. And that's that large yellow area is the main focus area for the placement on southern Gull. At the same time, we wanted to see if we could place near shore placements and create a marsh edge protection zone to try to create a more natural marsh slope instead of just these scarps of blocks falling off the marsh, creating a wave energy buffer. There's a channel that runs along that southern side. So we have a combination of boat wakes as well as a southerly approach, which is an important attack direction for waves here from wind-driven systems. We were trying to build up intertidal shoals, either right up to the marsh edge and then have it taper down to intertidal, which is about 2 feet, is the marsh edge elevation. And then we wanted enhanced intertidal subtidal shallows. And this is really taking the mean lower low water line and getting elevations up to mean lower low, which is where we see there's a big change in macro algal flat density. Right. Go to the next. This is a drone photo prior to the placement at Gull Island, and you can see the large area of unvegetated flats. That was one of the target areas we focused to the kind of to the right side of this image. And we did that in part because we went and we evaluated quality of marsh pools, and when we had very high quality habitat for both avian use surveys as well as SAB occurrence, we had Rupia marittima in some of these marsh pools that we didn't want to impact. We targeted the unvegetated flats, as I mentioned. We used benthic surveys and macroalgal assessments to set goals for the shallows and the mudflat target depths, and then we used marsh edge erosion assessments to pick where we wanted to do some of the edge features. These placements were just completed. These are September, October 2020. This is another drone photo looking, now I'm looking to the south from Gull Island, and you can see the placement area. We had marsh edge elevation. We ended up placing about 40,000 cubic yards of mixed fine sands and muds. We achieved about 21 acres of elevation lift, a significant portion of which got to 3.9 feet, and then it grades down to the south and away from the center of placement area to about 1.8 nav D88. Again, these are early. Some places we couldn't get yet. We'll have to see how much subsidence and dewatering we get with those final elevations are. We did preserve these high value pools. We did not want to get into. We did that very effectively. The marsh edge platform, marsh edge protection, you can see is up at MEP up towards the top of the slide. This was the placement that we did along the marsh edge that grades and tapers down to mean lower low water. And then we enhanced some intertidal shallows, again, by building up to mean lower low water. For Sturgeon Island, we had similar goals that I've already talked about for similar reasons. This is a picture of the of Sturgeon Island on the right. And as we began placement, we again targeted that shrub habitat elevation for the wading birds at 3.5. We will pick those numbers first to get above, high enough above mean high water, which is the 2.4 is an old epic, but also to get above frequent storm flood elevation for the nesting birds. We again wanted to create a sandy marsh edge protection feature. And then we were also interested in getting some of the habitat out there. And in the bottom picture here, you can see these macroalgal flats. You can see how densely vegetated they are. And they're densely vegetated when we get above that mean low and low water. So we use the same target goals for Sturgeon Island. And then here's where we got. This is, again, really early assessments. We placed in 2 phases. We started in March 2020. We got about 5 days of placement in before we had to, before this world shut down for COVID. So we only got about 4,000 yards placed on island for marsh elevation enhancement. In September, we came back and put another 15,000 cubic yards. Again, this is mixed fine sand and mud coming from the New Jersey Intracoastal Waterway. We ended up with about 3.5 acres of enhancement, but we only got up to about 3 feet, grading down to about 1.9. We need to do some additional containment approaches there. We did place marsh edge protection along that northwestern corner. You can see it's block edge erosion there, and we did get a sandy edge along there, and we did enhance some intertidal shallows. You can see on the opposite side there where we came up in intertidal along that edge. We do hope to return and place additional material in the next, probably in the next year or so when we can get back. And these other pictures that I'm showing here, we used a kind of an interesting technique where we try to distribute the material placement along a longer reach so that we could spread material more and try to separate sands and muds, and it worked fairly well. We did turbidity monitoring, and I wanted to share some of that data with you. This was background turbidity assessment that was done by the Army Corps Research Lab. And from October to December, we had fixed stations out there documenting that. In fact, these systems are very low turbidity systems overall, but we were able to capture 2 storms. We captured a southerly wind event storm as well as a nor'easter. And you can see we did record turbidity between 250, almost 400 NTUs. And then we did turbidity monitoring during placement as well as 1 month post placement. And what you can see is effectively we did have some higher turbidity, but it was really localized in scope, and it really wasn't significantly higher than what we see during nor'easter storms or storm events. The X's are the location where the discharge pipes were, and these were sampling surveys done while we were actively pumping and placing material. 1 month post placement, you can see in the bottom right, you can see there's very, very low turbidity. So these systems, once they were in place, really aren't bleeding turbidity. Once they're down, they seem to be down and in place. There's quite a lot of assessment and monitoring that's going on the pre-placement. We did obviously a lot of topographic and bathymetric surveys. Those will be ongoing post-placement. I showed you some of the wind wave, the turbidity monitoring. We're actively monitoring water levels and flooding elevations. We did a whole host of vegetation benchmark elevation surveys to set the target goals. We'll continue to look at vegetation response. The ERDIC team did benthic community assessments and macroalgae assessments prior to placement as well as in reference sites, and they'll continue to monitor how these subtidal features respond. We have quite a bit of data on avian site usage and nesting success, and we'll continue to work on that and then again track the vegetation response in these systems as we go forward. So I think these are some exciting projects. We're pretty excited to see how, especially the subtidal placements, how some of the marsh edge erosion protection pieces work. And really, we try to look at this. These are unconfined placements. We try to understand that some material is going to leave the platform, and can we direct it in a way that we want to enhance subtidal areas as well as the marsh edge protection. So we try to link things together. Thank you for listening, and if you have questions, you can certainly ask them now, or also check the websites, and there's a lot of material up on 7 Mile Innovation Laboratory as we go. Thank you.
Great, thank you, Lenore. We have a couple minutes for questions, so if you either want to raise your hand, or Kirk, if you'd like to read any of the questions that have come in.
Great, so we have one. Lenore, did you need to move the pipe outlet for either project?
Yeah, that's a great question. We actually designed it so we did not have to move the pipes. Because you really can't, if you've not done this before, once you start pumping, you really can't get back to your pipes because it's just, it's kind of scary out there with the soft, soupy, muddy sediments. The distribution pipe concept that I showed you from Sturgeon Island, that was designed to distribute material over about 150-foot span. So continue to spread that. And we also really relied on the tides and the flow systems on these platforms to move material around. So we did not move pipes. The subtidal placement where we did the Marsh protection, we did move it a little bit. We had the pipe mounted on a pontoon, and we pumped for a while in one spot, and then we moved the pontoon back to create a linear feature. But for the most part, we didn't move. That was the only thing we moved, and we only moved it once.
Great.
We have another question just came in. What approach did you use to protect the high quality pools during placement?
Yeah, so that's a great question. We used, so we're really trying to engineer with nature. So we tried to use the natural flow paths and flow systems. We sort of got a little bit lucky in the sense that the high quality pools were largely isolated by other tidal channels or higher area structures that were going to naturally divert flow around them. Where we had concern, we just used coil log placements around them to kind of protect the flow, to keep sediments from getting into them.
One last quick question. Do we need to establish a balance between channel deepening and marsh elevation so that slopes can be maintained?
Yeah, that's a good question. So for these particular projects, the channel deepening is the federal channel. It's the Intracoastal Waterway, and they're fairly far away from these sites so that we're not, that channel is not, in this particular area anyway, is not influencing slopes near the marsh edge. So, so that's not an issue here, but I could see where it definitely could be. And we have an opportunity to the south that we're hoping to do some placement on probably next year, where we do have to think about where a channel is, and in fact, the channel being close enough that it is causing marsh edge erosion. And to the extent that can we place sandy material along that edge and try to create a wave break away from it without having the material just slide into the channel. It's a balance, right? The Army Corps doesn't want to really dredge a channel and then put the material right next to the channel and have it slide right back into the channel. So those are the things we're starting to think about. But for these particular sites, we did not have that, that challenge to address.
Great. Thank you again, Lenore, for your presentation. I would like to now invite Mark Gallagher from Princeton Hydro to turn on his camera and his speaker, and then also share his screen. Mark will be talking about lessons learned from restoring the northernmost freshwater tidal marsh in the Delaware River. Mark?
I can't start my video. There we go. Can everyone see that?
Yes, we can see you.
Perfect. Never quite sure how this works. Anyway, we're going to be talking about a freshwater tidal marsh on the Delaware River called John A. Roebling Memorial Park, and it's just outside of Trenton, New Jersey. Here's our project team. So this was a project we worked with the county, Mercer County, as well as the Friends of Abbott Marshlands and U.S. Fish and Wildlife Service and a number of other folks. Now, Roebling Park is just a small portion of the Abbott Marshland complex, which totals about 1,200 acres. Head of tide is probably just a little over a mile upstream of this location. And so right here is the upgrading part. So head of tide's probably just off the slide to the north. Roebling Park is this little gem in a very urban area. Trenton's just north. It used to be just south of pretty industrial complex. So it's a pretty interesting area. And they're just some photographs of the freshwater tidal marsh of Roebling. So it really is a well-kept secret. For birders, it is a great location that very few people take advantage of. But like every natural area in our region, it's in a landscape that has a lot of anthropogenic impacts that create issues with the quality of the marsh. So the urban landscape, Trenton's off to the left, Hamilton Township, it's pretty densely developed area. Historically, the Delaware and Raritan Canal, which is right down here, there's a little segment left. The segment through Trenton is actually Route 129 at this point. There's a railroad, one of the first railroads in the country, the Camden and Amboy Railroad. More recently, they built a landfill, and of course, where does a landfill go best in a wetland? Power line corridors, and what you'll see is it's next to all those disturbances, and this brown is Phragmites australis. And these were very healthy stands. Some of the plants were as much as 18 feet tall. Like everyone knows, there's undecomposed biomass or litter layer of Phragmites in various stages of decomposition that lies over the marsh substrate. So working with the county, we developed just a handful of reasonable, attainable goals. You know, we sought to reduce the coverage of over 41 acres of Phragmites, and this again, just in the Roebling Park, part of the Abbott marshlands. We wanted to better understand the tidal hydrology of the site. Because we're close to head of tide, we wanted to get an idea of how far up into the marsh that was under tidal influence, and to identify any areas where the tides might be obstructed. We wanted to understand the seed bank, and we're working with Dr. Mary Leck at Rider University, who's been doing seed bank studies in the Abbott marshland for a number of years. And we wanted to improve the visitor experience. And this one might sound odd, but a lot of the Phragmites occurred next to trails. So as you could look towards the marsh, all you were looking at was a wall of Phragmites. So the seed bank studies were done in this marsh and in areas that we're looking to restore. And Dr. Leck just informed us recently that her study was approved. It should be published in the journal Wetlands in the near future. And the results of her study, she found 54 species of tidal marsh plants that were in the marsh. So our goal now is to, how do we get that seed bank to actually express itself? So our first step was to map the Phragmites and develop a plan for the treatment and management of those areas. And again, all these areas in brown, and these areas are following a power line corridor. It's all Phragmites, and this is the photograph on the left. You can see the landfill in the background, and where I'm moving the cursor, it's just the wall of Phragmites moving from the landfill waterward towards the center of the marsh. So here was our early map, and this was part of the permitting process. And New Jersey is not the easiest state to get permits. So there were two types of tidal marsh, ones that were mapped as coastal wetlands and one that were considered regulated under the Freshwater Wetlands Protection Act. And we needed separate permits for those. We also needed a permit for anything mapped as a riparian zone. Now, the state was very helpful and viewed these projects as positive. So it was a very collaborative effort. So I don't want to make it sound like it's negative. It's just complicated. And this is a more recent aerial, and it's very clear. And you can see these kind of bluish green areas represent the areas of Phragmites. This brown area was an area that was treated and rolled in the Phragmites in 2019. And those photographs of the nice area of the marsh are all these areas out in here. So our approach to the Phragmites management, we use the Mazapir. And as a previous speaker, we really did not want to use glyphosate. It was a very high profile project. And we actually find a Mazapir to be much more effective at the management of Phragmites anyway. We try to treat at high tide. So we minimize the amount of herbicide that might get into the substrate. And in this case, because of the thick layer of Phragmites litter, the herbicide really could not go that far into the substrate, and I mean the marsh soil. It would stay within the litter layer. After treatment, when the Phragmites was dead, we rolled the site, essentially crushed it, and then later looked at raking the site to expose the underlying substrate. So one of our permit conditions that we're trying to work with the state to get past is they did not want us to treat Phragmites within 20 feet of any woodland area. And it makes perfect sense until you're trying to hand wipe Phragmites that's 15 to 18 feet tall. So we're working through the permit conditions with the state now to be allowed to treat those areas differently. And it should happen this growing season. And actually this year's snowfall was very helpful. It laid all the last year's biomass down, so it should be easier to access those areas. Now, the rolling of Phragmites, as I said, it really is just to lay it down to facilitate raking. And if any of the Phragmites is still alive, it provides better access so we can treat those areas earlier in the growing season. Now, with this site, it was quite the chore. It's 40-some acres, very tall, robust Phragmites. And this is just the start of the rolling. Just another view, drone footage. So the photograph on the right, you can see our marsh masters almost completely obscured by the Phragmites. Now, this was the next step. Now that all the Phragmites is laid down, we still want to look at exposing the marsh substrate so we can see or allow the seed bank to express itself. But that rolled Phragmites was 12 to 18 inches thick in spots. Now, what we did see are areas that were exposed or raked earlier that the seed bank really did well. And the photograph on the right is just a mix of tidal marsh species that came up in the seed bank. And there's on the left, it's a little Biden's lavis that's coming up, a tick seed. And again, just another view of the marsh with the volunteer species coming up. Again, nothing was planted on the site to this point. And the photograph on the left, you can see it's mainly Peltandra or arrow arum, and it's starting to spread into those areas of Phragmites where we laid the stalks down. But in these areas, it was pretty thin. So it seemed to do well. As it got thicker, we've had virtually no recruitment from the seed bank. Now, the photograph on the left, that orange line shows what was the limit of Phragmites prior. And so you can see in the thinner areas of the stalks and where the litter layer was thinner, we were starting to get volunteer species establishing, and the photograph on the right shows the Peltandra coming up between the stalks. But it was mainly the higher elevations of the marsh that it was much thicker, and the areas we had the rake. So this whole area along the landfill was, all those stalks were raked out of there to expose the substrate. Now, this was just an early shot at new survey, but the stalks were still down. So mean high water in this marsh is about 4.5 feet. And this is the 5 contour here and here. But this area here, there's probably 12 to 18 inches of Phragmites. So when that's removed, the tides are going to be able to extend much further up into the marsh. Now, one of the things that was one of our targets with the Phragmites is with that thick litter layer, once it's removed, shallow water during a high tide event is going to move much further into the marsh than it does now. Now, it might now, but it's just not visible. But later, it's going to play a very important role in suppressing Phragmites seedlings from getting established. This is just a view of raking, and this was an area you could see that it, before it looked pretty dry, but as we started the rake, you started to see that actually there was water present in this part of the marsh. And just an aerial view, and that's Route 29 in the background, and the landfill is off to the right.
2 minutes left, Mark. 2 minutes.
Okay. So as we rake the Phragmites stalk, you can see more and more of the substrate exposed. Just another view. This was in the winter of 2020. And when the material or the Phragmites stalks were removed, you can see how well the marsh started to colonize on its own. It's just an area of wild rice that was Phragmites the year earlier. And it came up, the wild rice came up in a lot of places that were previously covered in Phragmites. Other species, mud plantain and water purslane. Again, you can see the wild rice in the background, and a number of other desirable tidal marsh species in the foreground. This is just a list of the species. It's not even a complete list of the species that came up from the seed bank. Lessons learned. We found a litter layer does impact or restrict recolonization of species from the seed bank. It also played a positive role in reducing the pesticides contact with the substrate, which would appear could affect seedling germination. Phragmites seedlings in the seed bank study were very dense, but were not found in the marsh after removal of the Phragmites. We believe partly because of periodic inundation. And this year we will be installing some other species to add to the species richness of the marsh. Thank you.
Great, thank you, Mark. Sarah, do we have time for questions?
No time for questions, sorry.
Okay, all right. So Jack, I'd invite you at this point. Well, we'll start with Mark, if you could stop sharing your screen, and Jack, if you would start to share your screen, that would be great. So our next speaker is Jack Szczepanski. I knew I'd mess that up. Jack, please correct me.
Szczepanski, it's all.
Yeah. Also of Princeton Hydro, and he's going to talk about Nekton monitoring to assess beneficial reuse of dredge materials in salt marsh restoration. Jack.
Thank you. Yeah, so I'm going to take this presentation from my backyard, actually, where the freshwater marshes that Mark was talking about, and kind of bring it back to the salt marshes in more southern New Jersey on the Delaware, that part of the Delaware Estuary. And talk about a study that was conducted by Princeton Hydro, led by Bob George, as is mentioned here, done with Green Vest in conjunction with NJDEP as part of a larger series of studies on beneficial reuse of dredge material, which also involved other groups like the Wetlands Institute, similar to the work that Lenore was mentioning in her previous talk, but a different operation altogether, Nature Conservancy and others. Now, our role in this was to monitor Nekton communities in relation to beneficial reuse of that material in the salt marsh at restoration sites. So brief overview, again, kind of bringing you back to the salt marsh after being in the freshwater marshes Mark was talking about. And discussing mostly what we already know, but again, trying to set the stage, and then talking about a beneficial reuse of dredge material through thin layer deposition, and how that impacts the faunal community, and why we looked at those particular species. Well, I'll go through basic monitoring methods that we used and breeze through the results in Fortescue on our Delaware Estuary side, and Avalon, which was our comparison site. I'll give you some take-home messages of what we learned, and some lessons kind of moving forward as we continue to try to use thin layer deposition for salt marsh restoration. Now, tidal salt marshes are extremely productive environments. They serve as nurseries for fish, crustaceans, mollusks, nursery grounds for all these species as well. They act as buffers to flooding from storm surge during severe storm events. As we saw in Hurricane Sandy, the damage was pretty severe, but could have been even worse without the presence of salt marshes. The Delaware Estuary in particular has very important salt marsh with regards to, say, like the Atlantic flyway, the interaction of shorebirds with horseshoe crabs, shellfish aquaculture, and associated economies really relies on the salt marsh for its productivity there, tourism. And most of the marshes in New Jersey are either moderately or severely stressed due to either erosion or the vegetation being stressed out due to extended inundation times. Some studies have shown up to an acre of loss per day of salt marsh. I just clicked in nothing's. There we go. So there are many efforts being made to mitigate salt marsh habitat loss, and examples of these include what similar to what Kenny Smith had described earlier in the first restoration and conservation session, living shorelines, which is essentially an alternative to wing walls and bulkheads, stabilizing the marsh edge and made of nature-based materials such as plants and rocks that tend to grow over time and reinforce itself, as opposed to the hard structures which are made to impede growth. Then there is creek morphology modification that is either in the form of increasing the number of small channels, which are called runnels, for facilitating water movement across the marsh and decreasing the inundation time. There's going to be a talk about that tomorrow morning in the, let's see, I think it's the second, no, it's monitoring assessment session at I think roughly 10:30. So trying to give some plugs here for some really interesting talks. And then finally, thin layer deposition, which is the application of a thin layer of uncontaminated sediments to areas of the marsh that exhibit stress relative to decreased elevation. Again, is looking at this relative to vegetation is where some would see the stress. But it's good to be able to use the material that's come off of the marsh, because a lot of our marshes do have sediment deficits, and put it back to where the elevation is needed. So again, taking the materials, this uncontaminated sediments, in the case of what Lenore was talking about from the intercoastal waterway, and putting it back on a marsh where elevation is needed, it's spread in a thin layer across targeted areas. And the alterations are localized areas for particular habitats. Now the increases in the elevation of the marsh, and sometimes it also is used in terms of filling in larger and expanding ponds, which tend to increase open water as subsidence happens. Now we're trying to do this in order to enhance vegetative communities, but this provides habitat for other organisms as well. And the impact on fauna community is not really well studied. So we used species of Nekton, which are free swimming organisms, fish, crabs, shrimp, that take advantage of these habitats at different life history stages for like foraging or reproduction, refuge from predators, overwintering, all different uses. And trying to understand a little bit better what we don't know of the thin layered impacts to those particular habitats and what it does to the populations of these various species, like the silverside. There's my point. There it is. Silverside, sheep's head, our momachog, our grass shrimp, and again, the economically important blue crab. So the Nekton surveys were conducted with GreenVest in 2015 prior to the placement of dredge material, and then after placement of dredge material in 2016 and 2017. It followed through a before-after control impact type design in Fortescue and Avalon. Nekton were collected with throw traps and ditch nets, which is a methodology that followed along with the USGS and US Fish and Wildlife Service sampling protocol, similar to that which is used for the salt marsh integrity plan. Various habitats were sampled in both untreated and treated areas in each of these locations. So we sampled at pools, tidal creeks, ditches, and the marsh shoreline edge. Now we recorded water quality measures, in situ water quality measures like temperature, salinity, and dissolved oxygen, as well as various Nekton summary metrics. We focused specifically on abundance, density, species richness, and did go into length, but what I'm gonna highlight here today is going to be more about the abundance and density as well as the richness. Now our two sites are as follows. We have our Fortescue sites on the Delaware Bay. The salt marsh there, the thin layer deposition was intended to increase overall elevation. We see it right here on the bay side. And then we have a back bay barrier island site in Avalon. And some of that placement is meant to alleviate the expansion of the open water pools. Now, on the maps here, you'll see the placement areas in yellow where the thin layer deposition was intended to take place in here, and then in Avalon up here, again, in yellow, with our various habitat types sampled with these points in different colors. Now, I'll go through Fortescue first. Here's an overview of the time series comparison of richness and density over time. There was a greater richness in the unrestored areas, but an overall increase in both. So we'll take a look there. The density did increase in the unrestored areas. In areas where there was thin layer deposition implemented, the restored areas did actually, they had a decrease in density post-treatment. Again, there was an overall increase in the unrestored areas. To give you some idea of our abundant species, I'm showing our density across time here, the actual numbers by species. You can see the lower richness, the lower number of species pre-treatment than after treatment. Pointing out our pretty abundant species, our killifish and mummichog, as well as the silverside and our shrimp. And then moving on to the baseline data for Nekton density in pre-treatments, which is now broken out by habitat type, by species. we have our, and then in 2016, post-treatment, first year post-treatment, we'll begin and look at the differences in richness. We can really look at a cross treatment now, because one of the things we're kind of seeing is the initial difference was lower numbers in pools. Excuse me, it's like my mouse is giving me some issues here. There we go. There's a lower number in pools in the treated areas than there were in the control areas. In particular, those two species. We have the Momachog as well as the grass shrimp and the killifish showing that kind of pattern. And again, in 2017, the shrimp are still fewer and less in the pools of the restored areas, but more in tidal creeks, while killifish were more in the pools of the restored areas as seen prior to placement. Now the silver sides are more in creeks and not in pools. So upshot is that the Nekton is more distributed across habitats in the unrestored areas, while more species appear to be concentrated in specific habitats in restored areas. The shoreline edges and ditches exhibited considerably lower Nekton abundance in restored areas compared to some of the control areas, and pool habitats have increased tidal inundation as compared with unrestored pools. So maybe that was, we're thinking that potentially the impact there. That should have moved, there we go. All right, now looking at Avalon for comparison to this, we see the richness has increased. There's a higher number of fish species and Nekton overall in the unrestored areas. Let's see, there we go. Density is increased in both the control and impact sites after about a year of thin layer deposition placement, but then density kind of stays pretty much the same. It's kind of static. There we go. Right there. I'm just having issues with my pointer. Okay.
2 minutes, Jack. 2 minutes.
Oh, great. Thanks. But again, there's a greater increase in control areas. Again, I'll show the, broken out by control versus impact sites here over time. And again, the most abundant species were pretty much the same with our grass shrimp, our killifish, the sheepshead minnow, Momachog. There's our main blue crab was in there too, is a little bit more abundant in Avalon site. Baseline density via habitat in 2015, again, just to give you an idea of what's happening there. In 2016, there are a couple of examples to show Momachogs are found more in creeks of the restored areas, and shrimp are found more in tidal creeks and shorelines than they had been. But there wasn't a clear pattern of transition across all species. When we look at the 2017 data, the Nekton were distributed across habitats in the unrestored areas, while the highest numbers are mostly in tidal creeks of the restored areas. So here's our, again, they're distributed across habitats, where in 2017, in the enhanced areas, it's mostly restricted to the tidal creeks. That was where the greater density of Nekton occurred. You know what, I'll just kind of skip forward to get to our main take-home messages. Okay. Unrestored areas tended to maintain a greater abundance, richness, and density than the restored areas of both marshes. That's not to say that it didn't increase in restored areas, but overall, that's where most of the increases seem to happen and were consistent in the unrestored areas. And compared to Fortescue, Avalon had a greater difference in the unrestored versus the restored areas, possibly due to a greater amount of thin layer deposition. I'm not 100% sure of that. We'd have to look at the elevation data to kind of see if that actually holds. Fortescue, there was an initial increase in species in restored areas, but then a decrease. So Nekton community appears to be affected by thin layer deposition. That's what we get. But proper restoration of habitats may take more than 2 years. So the Nekton community may not be exhibiting significant meaningful changes in the time frame that we sampled. So incorporating more integrated data will improve effectiveness. Lastly, the study emphasizes proper design and implementation and targeting habitats wisely, but also the need for the time series comparison as for context and to the changes that are seen between the control and impact sites. What was interesting was that the thin layer deposition seemed to have improved habitability of the adjacent areas. Maybe the organisms are moving out to areas that weren't as impacted, and the time series will actually show us a little bit more about how they may utilize the restored areas in the future. This is something we don't know, but it would be certainly something to keep looking at moving forward. And I'd like to thank you and all the rest of the speakers today. Here's my contact information should you have any questions, because I think I've burned my time. And
Thank you, Jack. Appreciate that. So we're going to roll right into our last but certainly not least presentation. Alison, I see you're up. Jack, if you'll stop sharing your screen if you haven't already, and then Alison, if you'll start to share yours, that would be great. So Alison Rogerson is with the Delaware Department of Natural Resources and Environmental Control, and she and her colleagues have been doing wetlands work for a very long time. But today's Alison's talk will be on restoration of Delaware coastal wetlands using dredge materials. Alison?
Thank you, Martha. All right, again, my name is Alison Rogerson. I'm an environmental scientist with DNREC in the Division of Watershed Stewardship, and I'm happy to be here today to do a quick lightning talk on a wetland recreation project that we are undertaking to use dredge material to not only, and we're building on the experience we have of a thin layer project to boost a tidal wetland, and now trying to demonstrate how to use a thick layer application to recreate a former coastal wetland. Our project is, you can see, all the way down in Sussex County, tucked away up the Indian River, almost up the Indian River, right into Millsboro, and you can see that our project area is tucked into a little cove, right in between some development and up against a road. So certainly some consideration for infrastructure going on. We selected this site because it is owned by the town of Millsboro, which makes it somewhat simpler for logistics. And also because when looking at aerial photography from over the years, we saw that there was a considerable amount of shoreline retreat, a lot of erosion occurring. We've seen this is a great example of wetland migration, coastal wetlands moving up towards the upland and converting a lot of forest habitat into high marsh, which is dominated by Phragmites right now. So a lot of habitat conversion going on as well. Also taking into consideration looking at some of Delaware's sea level rise bathtub scenarios for 1 and 2 feet, that the fate of this site is not great. That water line is going to continue to creep upland. It's going to be threatening. That's a small water treatment facility right against a busy road, and then there's a cemetery across the street. So certainly some infrastructure considerations in selecting this site as well. So currently the site is dominated by stumps, snags, and Phragmites. So this is a view of it from the water. In the foreground, you can see a lot of brown. Those are old stumps from the former forest that was there decades ago. It's very interesting to be out there at low tide. Lots of standing snags in the background. And then the high marsh is dominated, 95, 97% Phragmites. So it's in rough shape right now. And so we're very interested in coming in here in 2 different phases to do a wetland restoration project. Phase 1 is addressing that 8 acres of high marsh. We want to restore that high marsh into a native plant community, eradicating the Phragmites, bringing in a nice mix of high marsh plants to restore that habitat for all the benefits that provides, but in addition to providing us with some security for our phase 2, that this Phragmites is not going to continue to move down and take over the rest of our project. So this involves, getting rid of Phragmites. You need a lot of herbicide treatment for several years. We want to remove that dead thatch either manually or by fire, by burning it off, and then hand seeding it with a nice mix of high marsh plant species to bring all those great habitat benefits back that'll be better than having Phragmites there, and securing the next phase of our project by not allowing Phrag to move in. So phase 2 is where things get really interesting. So 5.5 acres of former wetlands, former tidal low marsh. So we want to come back in and reestablish our wetland platform, and back to a historical extent, which is back to the 60s roughly. And to do that, we need to provide some containment, obviously, and then fill that area with dredge material that is coming from the adjacent navigable channel, Indian River, that needs to be dredged very often. And our goal is to bring it up to about 0.3 meters NAVD 88. So that's just below where Phragmites wants to live, but it's in the growing zone of alterniflora. We're taking into account sea level rise for future sustainability. It requires quite a bit of sedimentation. You can see the thickness is up to 75 centimeters. So that containment is going to be very important. So coming in here over several years, making several passes with sediment, adding that in there. In the meantime, we are doing a lot of baseline monitoring. So we've been out there for over a year, collecting all kinds of physical, biological, and chemical data, trying to get a sense of the conditions that are out there. So how best to design, but then also, yes.
1 minute.
Thank you. Also getting a sense for when things change, how we can compare back to the original baseline conditions. So that's been a lot of fun. Our project timeline, we've already been out there. We've had 2 applications of Phragmites spraying, collected a lot of baseline data. Looking forward into 2021, we're going to be putting our heads together and getting some design, some engineering, so that we can move forward with our permits, with hopes to apply in the fall, come back again in 2022 and apply again. And then in 2023, be able to adaptively manage, continue to monitor, and then plant the high marsh and the low marsh, so we have a nice restored wetland. So we're very excited for this project. Lots of new things to learn. We're some steep learning curves. It's been very interesting, and we're excited about the prospects of demonstrating this thick layer application in Delaware for wetland restoration. Thank you.
Alison, thank you for that lightning talk. And I can say that we'll all be interested to hear an update come 2023 at the next science conference. Sarah, is there time for additional questions, or we need to wrap this up?
We'll just open it up to all presenters now for all questions.
Okay.
I know there was a few in the box. We can go a little over 3:30 if we want to get to it.
All right, Kirk, do you want to take it away?
Sure. So I think this question is for Jack. From a fisheries perspective, do you think thin layer placement had a positive effect?
So at least at Fortescue, we did see that the thin layer placement, at least in the areas of thin layer placement, the species richness had increased despite density decreasing. So that could indicate that there was more, maybe they spread out more. That would be something I'd have to, I'll dig into, but I think it could have a positive impact. That would just be really something that a greater time series would really help with answering, because then we could really say, okay, maybe it was a fluke, maybe that second year after placement, maybe there's something else that happened, and I didn't take into account necessarily all the other factors involved with storms or tidal stage during sampling and things like that. So that's something that also would need to be looked into. This is pretty cursory analysis of that, but I'd like to think it should. Again, but the data don't necessarily indicate that yet, but I wouldn't discount it.
All right, and another question kind of related. You kind of hit on it a little bit, but based on life history and age structure of a marsh Nekton community, do you have a timeline guesstimate for how long it should take for communities to match each other? would it simply be the time needed for sediment biogeochemistry, flora and infauna to adjust, or might it be faster or slower given the mobility of Nekton?
That's a really great question. And very complicated question to answer for that exact reason. There's just so much involved. And I saw that Dave was indicated that, you know, the mobility of the Nekton I think it could help them because they can kind of vacate some of these areas, and then if they can come back to the habitats once they're a little bit more, I guess once the conditions become a little bit more amenable, once the vegetation starts growing, they have more food options as well. Something else to look at would be some of the epibenthic fauna that are also impacted, and potentially food species. And so that's something else that I would want to understand a little bit better before giving a full solid answer to that question. But again, it is a very complicated question. So that's good. I'm not sure.
One last question. Jack, how and why were certain sampling sites, pools, creeks, edges selected?
I believe it was, and I might actually want a little bit more clarification on that. The specific sites themselves or the habitat types? I think that's that is kind of
habitat type. And Jenny, feel free to, if you want to raise your hand.
Yeah, I think that's mostly indicative of what's going to be most utilized by the species that we had and that we were trying to look at. Again, the shrimp, the various species of fish are going to be traveling through the creeks. They're going to be traveling through the ditches. They're going to be utilizing the marsh shore edges for shelter, potentially for foraging.
Lenore, are you up there?
And yeah, so there were reasons why those sampling sites were chosen. They were important to the life history stages of each of these different species. Yeah, hopefully that answered the question. If not, get back to me. Ask me clarifying questions for that.
All right. Any last minute questions? Speak now.
Well, if not, thank you to all our panelists. I really appreciate all the work that you're doing and taking the time to present to us today. At this point, I'll hand it back over to Sarah. We'll wrap up the session.
Good. Look, we have, because we went a little over, I see one more hand up. Kurt, we can do that.
Mattia, go ahead and unmute.
Yeah, hi, Jack. Thank you so much for presenting. I helped work on these projects, and I just wanted to comment that because we were targeting high marsh at Avalon and Fortescue, and in some cases that meant that we were attempting to decrease the size of expanding pools, that we expected that in some cases where we were reducing the amount of water on the site, that there would also be a corresponding reduction in Nekton. So I don't think, that's a negative reflection on the project. It was something that we expected, but something that we just wanted to measure.
Excellent. Thank you for pointing that out, Mattia. Yeah, as I wasn't directly a part of this in the inception of the project, but yeah, thank you.
Okay, I don't see any more now. So we'll call that good. Thank you all for attending. We have about half hour if you want to join our next one. We have another living resources all about shellfish, and I can't remember the other one off the top of my head. Coming up next, water quality all microplastics. So please join those sessions at 4 o'clock. I'm going to put 2 links in the chat right now. First is to our sponsorship profiles. We really appreciate if you check those out. We couldn't do this without our great sponsors. And then the second is our pre-recorded and poster presentations. we have our first poster session tonight, and if you want to have a couple minutes now to look at some of those ahead of that session, that would be great. Okay, hope to see you again at 4. Bye.
Thank you.